Welcome back. We're still talking redox reaction, and let's continue having a look at the galvanic cell. Now look at what is happening here. We said that the galvanic cell converts chemical energy to electrical, right? So this chemical energy inside here is converted to electrical energy up there. And we are saying that the zinc electrode is losing electrons. Those electrons get into the wire. This is what we call the external circuit, which is through these wires here up to there. Okay? These electrons get in there. They may pass through a bulb there and will cause the bulb to light up, as you can see. So that is the path of the electrons. Electrons move on the outer circuit. Inside here, the salt bridge. Inside the salt bridge, it's ions moving. They move from both sides, so we'll have ions moving from this side to that side as well. But you have to know which ones are doing that. So ions move through the salt bridge. Sorry about that. So ions move through the salt bridge, whilst electrons move through the wires outside. Okay, now, look, from the salt bridge, this side, the Cu2 plus ions are taken out of solution. If they're taken out of solution, you are creating a charge imbalance inside that solution. So the salt bridge will bring in anything that is positive this side to balance, to neutralize, to keep the neutrality there. If the solution on the salt bridge is made up of potassium nitrate, for example, the potassium ions will be coming this side. So positive ions are called cations, hence this is also called the cathode. It takes the positive ions. This side, you're putting in more and more of the Zn2+. You need to balance them by something negative. In this case, your NO3 will be coming this side. Therefore, this one will be attracting the negative. It is attracting the N ions. It is therefore the anode. Okay. Now, quickly, let's move on. When we have a galvanic cell, we can be able to find out its EMF. To do that, we consult the table of standard reduction potentials, okay, or reducing potentials. In our case, we've got zinc, which is having that potential, and we also have copper with that potential, okay? Now, how do we find the EMF of the cell? The EMF of the cell is found by this. The EMF is equal to the E cathode minus the E anode. Okay? In our case, what was the cathode? The cathode was the copper. So in here, we will check our table. Okay? And from the table of reduction potentials, we'll put in plus 0.34. Okay? So hence this one here. In the same way, this is the minus, this one here. In the same way, the E naught for the anode for zinc is minus 0.76 V, and therefore when we work that out, we come up with 0.34 V plus 0.76 V. What do we get at the end? We get plus 1.1 volts. And I have written here spontaneous. If you calculate for the EMF of the cell, galvanic cell, and find it to be positive, it will mean that that cell is spontaneous. It happens naturally if you set it up in that way. But if you happen to calculate for the EMF and find it to be negative, it tells you this one cannot happen. It cannot happen spontaneously. You would need to force it to happen. Okay? So this one will be a spontaneous one because it is positive. Okay. Now, we also know that when we talk standard reducing potentials, it means that those cells are set up under standard conditions. So let's revise that quickly. Remember, we said the temperature must be 25 degrees Celsius or 298 Kelvin. And the concentrations of the solutions in this case should be 0.1 mole per cubic decimeter. Now, the condition on pressure does not apply on this galvanic cell we're talking about, the zinc copper. Why? Because there is no gas. There is nothing that is gaseous there. The third one, which is pressure, okay, will apply if we're having a galvanic cell that involves some substance that is gaseous, like hydrogen, oxygen, nitrogen, whatever gas you may think of. So when you are asked in the exam to say which standard conditions will apply to this specific galvanic cell, be careful. Check what the galvanic cell gives you. Does it give you something that is gaseous? Then pressure will apply. If there is nothing gaseous there, then the pressure condition will not apply. Hope you have learned your lesson today and you have enjoyed this lesson, hopefully. Keep well and keep watching Matrix Uploaded for your benefit. Bye-bye.